So let's look into a code-based demonstration to understand the implementation of decision trees. Now, in the examples that we have looked so far, like linear regression and logistic regression, we missed out a very important thing, and that is the including categorical variables as independent features. So if you remember, in linear regression as well as logistic regression, we've always used, till this point of time, independent variables which are numeric in nature. What if we had passed something like gender, which would have values like male and female? If you assume that the Python ecosystem will take care of that, that assumption would be incorrect. We'll actually need to augment the dataset into a format where it's converted to a numeric form and then pass on that to the Python ecosystem. If you forget to do it, it won't interpret categorical variables on its own. Like if you pass a string, it doesn't interpret that as a categorical variable. It'll throw you an error. So in this use case, for decision trees, we'll pick up the example from the HR analytics dataset. So the HR analytics dataset, which we used in the previous example, we leverage the same one over here for creating a decision tree classifier. And in this one, we'll take up a few categorical variables as a part of the independent features. And then we'll also look into use cases where we can augment them for an ideal scenario. So let's import pandas. I'm also importing decision tree classifiers, which is hosted under tree segments for sklearn. And I'm also importing another function called export underscore graphviz. This will be useful to visualize the decision tree created. Now let's import data. Now that we have the data in memory, let's do a quick validation. We'll say df.shape, and then we have 15,000 rows and 10 columns. And we'll say df.columns. There we go. Now, for this use case, let's try to define a classification scenario where we are trying to predict the attrition of an employee as a function of work accident, which is a categorical variable, salary, which is another categorical variable, and let's say that's it, two of them. Now, we'll create a simple decision tree with two independent variables and one dependent variable. And in this scenario, both of the independent variables are categorical variables. So how do we augment the categorical variables to a numeric format? Let me give you a visual example to help you understand this better. So for simplicity, assume you have a data set where you have, let's say, variables like age, height, gender, and weight. For let's say age 10, height 120, or let's say 82, gender male, we have let's say weight as 80, age 12, 75, female, we have 89, and age 14, 80, male, we have weight as 90. This is a hypothetical data set, and the problem would be, let's say we're trying to model weight as a function of age plus height plus gender. Now compared to the previous examples, we can see that age and height will be fairly straightforward. Gender will be a problem because it's categorical and we have values like male and female. Now the easiest way to go ahead and convert this to a numeric format would be use gender mapping. We'll say male is equal to 0 and female is equal to 1, or vice versa. In some scenarios, let's say you have a categorical variable, let's say something like class, and you have values like A, B, or C. Now in such scenarios, you can create three different columns. So you say class of A, class of B, and class of C. Now let's say when the actual value was A, you would say this is 1, this is 0, and this is 0. When the actual value is B, this would be 0, this would be 1, and this would be 0. And when the actual value is C, this would be 0, 0, and this would be 1. So this process of converting a categorical variable into three columns is called one-hot encoding, where you'll have a binary flag representing each class of that categorical variable. Now, for this process, for decision trees, you actually don't need to create three different variables or columns from a categorical variable. You can just convert that column into a categorical column. And the Python ecosystem understands that this is a categorical column only when it is numeric. So for example, let's say you have something like gender and values like male and female. This will not be acceptable. But then let's say you have something like gender and you have 10, 10, and then you tell Python that this is a categorical variable, that would be still fine. Now the system will be able to encode it. Now let's see how we can do both of them. This method would be what we require uh, for decision trees. Now, if you're dealing with something like decision linear regression, logistic regression, or some other algorithm, we will need to use this strategy. Let's see how we can do both of them, and then we'll implement a decision tree algorithm. So let's look into the data set. Now we have defined that we'll take salary, we'll take work accident, and we'll take left. So we'll define left as a function of work accident and salary. Now, if you look over here, you'll say df and work accident. Look at the values. Now, these are work accident. Oh, it's new df, sorry. But we have values like 0 and 1. If you take a unique, you can see we'll have values like 0 and 1. Now, we can simply convert this to the form of categorical. So I'll say new df of work accident is equal to new df, and I'll say as type and push the format of category over here. Now if I execute this, this data type will now be a categorical data type. We can open up new df and you'll say d types. If you check the data type over here, we can see work accident now resembles category. We need to do the same with salary. But if you explore salary, you'll say new df and salary dot unique. The values are not 0 and 1, it's low, medium, and high. So we first need to convert them into numeric form. There are different techniques by which we can achieve this. Now the easiest one would be we leverage something internal to sklearn. So sklearn provides a very sophisticated library called preprocessing. So from sklearn dot preprocessing, we import label encoder. Now the way we use label encoder is something very similar to the machine learning algorithms we have used earlier. We do a fit and then we also do a transform. And label encoder also provides you a function where you can do fit and transform together. So we'll first create an object and instantiate that. So we'll say label encoder. Then we have it ready. Now we'll create a fit form of label encoder. We'll say le.fit underscore transform, and we'll pass in the column name that we would like to encode. So in this scenario, we'll say new underscore df, and we provide salary. And now we'll store this into another variable or another column. Let's say we'll call that salary 2. I've been making a lot of keyboard mistakes. I'm a little new to this keyboard, and that's the reason why you see I have made a lot of typos and I keep correcting them. So let's execute this. You'll see we have created a new variable called salary2, and we have transformed this as a categorical variable with numeric values. Now, if you just look at the values over here, you'll find that we have labels like 1, 2, and 0. Now all you need to do is you can just create this as a category. I'll say category, and this will become a categorical variable that Python can understand in its internal system. If you look over here, we have a new variable salary, we have another variable work accident, and we have another variable left. Now left is also a categorical variable, but then it is in integer format. But then if you use decision tree classifier, it kind of assumes that the y variable is a categorical variable. And since we're passing 1 and 0, it takes care of it on its own. So now let's create a decision tree classifier. And before winding up this session, we'll also look into how we can convert salary into a data frame with 3 extra columns, where we'll have salary low, salary high, and salary medium as 3 different columns. So we'll instantiate a decision tree classifier object. So we'll say decision tree object is equal to decision tree classifier. Now we can pass in a couple of parameters over here. Then for now, I'll just leave it empty. Now the parameters you'll pass over here will help define the algorithm that will run in the backend. So if you remember, while we were discussing about decision trees, we discussed the kind of algorithm that will be used to select the root node and subsequent nodes. A couple of extra measures like the threshold required to select the minimum number of nodes in each leaf node and so on. So those parameters, you can set it over here while instantiating this object. But for now, I'll keep it blank. Now let's say df.fit, and I'll pass x and y. So over here, x would be new df, and we'll pass in the columns which we have recently created. Salary 2 and work accident. Now this is x, and y would be new df of left. If you try to run this, we fit the equation and we get an output. Now you can actually go ahead and do a simple scoring over here, just like we have done for linear regression and logistic regression. So dt.predict and dt.predict probability, both of them can be used to predict the actual outcome or the probability. So if you just have, let's say if we just use one of these rows, you can use the same output actually. This is not the right way to test. We'll get into the test functions later on in a very detailed way. If you try to test this out, you get the output as 0, 0, 0, 0. Now, the ones you see over here all seem to be 0, but then I'm sure the output will definitely have a couple of 1s also. So the rest remains the same. We use a couple of input variables, that which will be independent variables, dependent variable, which is your y variable. We'll fit that into a decision tree, and that decision tree can be later used to predict the actual outcome or the probability values. The same process, you can repeat it for regression. Now, just instead of importing a decision tree classifier, you can import a decision tree regressor. So that will be decision tree regressor. Rest remains the same. The steps which have enlightened over here, all of them remain the same for building a decision tree algorithm for regression. Now, this is one more thing I would like to showcase before we wind up the topic, decision trees, and that would be for salary. So since salary is a categorical variable, we converted that to a one-hot encoded label. What if we wanted to create 3 different columns? So we have encoded the labels in a numeric format, and that is stored in the column salary 2. Now, Python framework under sklearn provides a direct module for one-hot encoding, and that will be available under preprocessing. So we'll say from sklearn.preprocessing import one-hot encoder. Now, one-hot encoder takes in numeric variables, takes in a numeric value and converts them into a one-hot encoded sequence. So, for example, let's say you have a column which values with distinct values of 1, 2, and 3. It will create a one-hot encoded sequence with 3 columns. Now, how does it look like? Let's say we just do the same for salary 2. Now, we'll say a temporary variable is equal to one-hot encoding. First, we need to instantiate that object. So one-hot encoding object. So OHE is equal to one-hot encoder. There we go. We've instantiated the object. I will say temp is equal to OHE dot fit and transform. And here we would pass the object new df salary 2. Now this is a numeric column with values of 0, 1 and 2. And we'll convert this to an array and we'll run this. So if you look at temp, here we go. We have 0, 1, 0, 0, 0, 1 and 0, 0, 1. These are the values that are getting stored in the array. And this is a 3-column array. We have the number of rows same as the number of rows in the data frame. And it is, instead of creating 1 column, it has created 3 columns. And each of these columns represent a binary flag for each of the levels in that categorical variable. So to make it more simple to understand and easily comprehensible, let's create a data frame which will have the respective column names in a more easily readable format. So we'll define column names. So we'll say column names is equal to salary, and we'll concatenate that with the different labels we have in the label encoder. So we'll say X for X in le dot classes. Now, this is another format of creating a list where I'm saying create a list where I'm concatenating salary with X, and I'm defining X as for each element in le.classes. So if you open up and just run le.classes, you can see it will have the classes like high, low, and medium, which was used to create while in the first step. I'm using the same to create a list of column names. So if you open column names now, you can see it has values like salary high, salary low, and salary medium. This is the exact same sequence as we have with the one hot encoder sequence. Now we create a data frame. So we'll say temp is equal to pd dot data frame, and that data frame we pass temp again, and we'll say column names is equal to column underscore names. Now this creates a data frame with 3 columns. If you see this, here we have it. Okay, let's do a simple head command. That would be easier. I'll say temp dot head, and I'll say 10. Here we go. So we have 3 columns: salary high, salary low, and salary medium. The salary high represents 0. So salary medium represents a particular value like 1, when we have the value over there as 2. Now this is one hot encoding for the column salary, which had values like high, medium, and low. Now we've created 3 of those columns. Now this can be concatenated with the main data set. We can just use the concat statement. So let's say you're creating a new data frame. You say new df2 is equal to pd.concat, and I'll pass in a list of tables. That will be new df and temp, and I'll say axis is equal to 1. Now if I concat them and if you do a new df2.head, you can see that I have concatenated the 3 new columns towards the end. And if you check the size, new df.shape, we have the same number of rows with more number of columns. I missed it. It's new df2. Yeah, there we go. So we have 14 columns and the same number of rows. So this is a technique where you can use to one-hot encode categorical variables before processing categorical variables for machine learning algorithms like linear regression, logistic regression, and a couple of more that we will explore in the coming sessions. So that's it for decision trees. It's a fairly straightforward and a very easy to understand topic. There's one last thing I would like to showcase before winding up. We have created a decision tree. We have leveraged the predict function to predict the output, but then we have not understood how it looks like. Now, while learning decision trees, we saw a very simple and easy to understand decision tree. But then there is a function within sklearn which can be used to visualize your decision tree. So if I'm using the same, I'll say export graph is, and I'll pass the object of a decision tree, which is dt. I'll pass a path where I want the file name to come. So I'll just say, let's say I have the same path. I'll pass in something, let's say like uh, test.dot. So dot is the extension for a file that is created by graphic visualization, and it will be a list of values which indicate a directed graph. Now if I just run this, and I'll pass in the features also. So I'll say feature underscore names is equal to a list of the features that we have provided for the algorithm. Now the values were salary 2 and work accident. So just say salary 2 and work accident. Alright, here we go. Now if you run this, it has created a dot file in this location. Now there are two ways to visualize this file. One is using your internal local system. It's easy for Linux. For Windows, you need to install an external package. But then if you don't want to do that, you can use a Jugaad way, and you can just open up this in a Word file and go to web and open up webgraphviz.com. These guys have provided a cool way where you can just visualize your entire graph. To generate the graph, you can see it has created the decision tree for us. So it shows that work accident greater than 0.5, true, false, come over here, salary 2, and then it has created the respective decision nodes and root nodes. And you can see the root nodes and how it has created one root node, and it has used the Gini criterion. Now, if you instead of Gini criterion you want to use entropy criterion, you can just add in that parameter while instantiating that object, and this technique will change. Now, looking at these values, we learned how to improve a decision tree. But before learning how to improve a decision tree, we need to understand how to evaluate a decision tree or any machine learning algorithm. That we have kept for the later sections. For now, let's move on to the last part of machine learning introduction, that is unsupervised learning. So we finished supervised learning till now, where we have explored linear classification and regression. So in combination to that, we learned linear regression and logistic regression. And then we looked at decision trees, which help us understand a neat way to perform regression as well as classification problems, which help us solve regression and classification problems. Now, just a word of caution, these are not the only algorithms that will help you do this. There is a wide array of topics or algorithms that will help you do this. So this is just an exploratory note. We're just trying to explore a few things that will come under supervised learning. So that's all for supervised learning. Let's move on to unsupervised learning.